All right, everyone, Mark here with the Hawk. It is a Sunday afternoon and a beautiful day. Overexposed, but beautiful day for late summer, early fall. Gavin's out exploring the runway right now and watching for traffic, of course, at the same time. So one of the many things I'm hoping to get accomplished today is to change this flat bracket. It has been broken at one time and actually welded. It's functional, but it's ugly. So this is a good opportunity when I don't have the sails on to go ahead and change it. So I'm going to go ahead and drill out the rivets. If you've never seen a rivet drilled out before, you take the same size drill bit, in this case a number 30 for an 1/8 inch rivet. You center it, and I'm going to drill. I'm going to move the drill around a little bit, and the idea is you want to drill the head off and not go back through the hole. You do not want to oversize the hole. And sometimes you do have to punch through the hole, and it'll happen. So you want to make sure that when you start getting close that you stop moving it around and you're actually square on with the hole, so that you don't oversize the hole. Here, I'll demonstrate. And there, it's off. And the hole is still clean and not oversized. If we can focus here, hang on. You can kind of see it. So that's what we're doing today. Okay, so I've got the old flat bracket drilled out, and here I have the new one, and it has holes already provided in it, and it looks like the old one did too, thankfully, and they match up. So I've actually taken the new part, or the old part, and laid it over the new part and ensure that the holes match. If we bring it over to the airplane, and of course I got the actual flap handle in the way right now, but if we just kind of stick it in there, you'll see the holes match up perfectly, and I can actually cleco that in place. But first, I'm going to clean up this part. Being brand new, it needs to be deburred, just like the old one. I need to kind of round out some of these sharp corners. Also, I think that the old one could have used a little bit better deburring too. There is a bit of erosion on the flap handle, and I think I'm going to remove the flap handle and clean it up a little bit as well. You can see here some of the erosion over time, and so we're going to give that a little cleanup and just help to not have any parts wear, hopefully, as badly. Now this is what this looks like after 376 hours. It's pretty inexpensive to replace if I have to replace it again, but hopefully the new installation can live a little longer. We'll see what we can do there. All right, everyone, Mark here with some Hawk parts down in my basement again, where it's beautiful outside. Another gorgeous, kind of an Indian summer day that I'd love to be flying, but yeah, I'm not. So anyway, here's the flap position bracket, the flap detent bracket, the new one I got from Hawk. And here's the old one that I'm replacing, and as you can see, it's been broken and someone has welded it. This older one is made out of a thinner gauge material than the new one, so I'm assuming that the change was made to prevent, some of what we see here, and also you can see it kind of gets wallowed out, or this one did. So I've cleaned up the outside with my Scotch-Brite wheel, but getting in here, this all really needs to be cleaned up to not wear on the flap handle. Hopefully not as badly as my old flap handle. trying to find anything to get in there in kind of this 5/32 space is hard. I went and got a Dremel grinding stone. This is the only thing I could really find that was small enough. So we'll give that a try and see if we can get in there. I'm gonna round some of these sharp corners. Looks like the laser cut profile for this old part already did that, but the new part does not. So I'm gonna round these and just really try to get all of the laser cutting marks. They look like saw marks. You kind of see it here, and you really need to get rid of those. One, because they're stress risers. It's like the notch in a potato chip bag. That's where something's going to break. So, for instance, the old one broke down at the bottom, and they welded it. That could be partially caused by an area that wasn't deburred, and it had one of those tooling marks, and that's where a crack starts when an area gets worked and stressed. So I need to clean all of that up and not drastically change the shape of it, but sand it and clean it up nice. So hopefully the Dremel tool does the trick. We'll give it a shot. I'm gonna try starting on a slower setting. I don't want to burn through this material too bad. The other thing that makes this hard is that it's a cone, so it's hard to make sure that you're getting it even here. I don't know how well this sanding stone is really working. It might be making it worse. I don't know, I'll try a little bit more and see if I like the finish. I need something better for polishing. I'm going to try this a little bit on here, this now scrap piece, so I can be a little more aggressive. So as you can see, I don't know how well you can see the light there, but I mean, it's almost leaving the same kind of finish as the raw laser cut edge. So I'm not so sure I like that. I might just have to get in there, really tedious work with a Scotch-Brite pad and do it. But I think what I will do is at least just round these corners with this. And then I think unfortunately, I'm going to have to take over with a Scotch-Brite pad and work it by hand. All right, so I've got a Scotch-Brite pad kind of wedged in here, and it's actually a little bit thicker than the space, if you can see the other side of it, Gavin. And I'm just going to have to do this, which is going to be a little tedious and probably take a while, and I'm probably going to rub a bunch of holes in the Scotch-Brite pad, especially from these sharper parts. I haven't gone back in with the Dremel and rounded these off yet. I'll do that before I really get to work on this, but I think this is the way that I'm going to have to deburr this and smooth out the edge. So going to be a little bit tedious, going to take some time, but a little elbow grease, but we'll get her done. All right, so I've done a little work with the Dremel. I've rounded these parts out here, and I'm also going to be doing these corners just to reduce wear on the flap handle. I'm also going to do this. This is an interior square corner, which is also another stress riser. And considering that even though my old one was thinner gauge material and it had obviously cracked at some point, which is why it had been welded, less likely to happen with the thicker gauge material, but I'm still going to round this one out in particular to eliminate that stress riser. I'm not so concerned about these, but I might still round it out again just to kind of help reduce wear on the flap handle. I kind of did the feel test here and the fingernail test, and although it didn't look great, it kind of, when I look at it closer, looks like what it would look like had you used sandpaper. So I think I am going to, it's smoother than the rough laser cut edge, so I think I am going to go ahead and sand all of these interior surfaces with the Dremel stone, again on the lower speed, so I'm not cutting. And that ought to reduce the amount of work I have to do with my Scotch-Brite pad. So we'll keep going. Okay, so I've been at it with the Scotch-Brite for a while. I cut them into strips and working them in the notches back and forth with two hands. It's quite tedious, it's a lot of work, and of course it kind of tears these to shreds, so you're working with them as they're constantly breaking, but we're getting there. It's starting to polish up nice, and I'm just about done with all the interior polishing. I'm just going to give it some more surface polishing. You can see here with the Dremel, I kind of hopped out in a couple of places, and I got these surface scores, so I'll polish all of those out. The rule with stress risers, if you can catch your fingernail in them, then they need to go. So that's the fingernail test that we use, and want to make sure that everything's polished nice and smooth, and that'll avoid cracking from fatigue over time. All right, so I ended up going at it with a little bit of 220 sandpaper in some of those spots where the Dremel hopped out, and you can see it's cleaned up pretty nice. Although, you know, not perfect, but definitely contoured out. So this is after some 220 and then a little more Scotch-Brite. So we're going to go ahead and do the other side, and sand spots where needed. Actually, I don't think there are any spots on this side, maybe one or two, but we'll get it looking like this and we'll be all set. Okay, so the enemy of progress is perfection. So in that spirit, I'm going to call this done, and this is perfectly good, but it's not perfect, so I'm going to make a new flap handle. And I started to clean it up the other night, some of the scratches and the scoring with the Scotch-Brite wheel, and it's fine, but you know, there's some pretty deep cuts in it. And let me sit down here. This piece of Deburring was glued on here sideways, which only protected some of it, and not all of it. So I thought, well, maybe I'll glue this back on this way. Someone had actually reversed this thing, turned it around. It's a fairly symmetrical part, and someone was seeing the scoring after, you know, 100 hours or however long on this side, and he ended up riveting a doubler on it, and then flipping it around, and you can really see that because there's holes for the flap drive tube on the end that the handle is on that match the holes on the other side. So this is really kind of what pushed me over the edge to want to remake it, not because these holes are here, but because when I pull full flaps in the airplane, or try to, the flap handle, it's kind of a Johnson bar type handle, and when you're pulling it with your left hand and you're pulling down at this angle, the handle wants to slip off. And so I had trouble getting full flaps like ever, because when I wanted them, because the handle kept slipping off in my hand. So what I want to do is I'll make a new one. It's just simple, you know, probably a leg of extruded angle cut off, or just strap stock. Looks like 1/8 inch. And what I'm going to do actually is cut some finger dents in there. And then I got some plastic dip, and I'm going to go ahead and dip the handle. And just to kind of clue you in as to how kind of anal I can be, I plastic dipped the hooks on my trailer because I didn't want to scratch up the trailer hitch on my new Jeep. And it's working great. I did that a couple of years ago. It's really tough stuff. It wears extremely well. It's also not especially grippy. And because of that, and the fact that it's so tough, I'm going to do thicker layers where the handle is. But further up, I'm going to do just a couple of layers up in this area. And not enough to get so thick. Obviously I can get at least this thick, which won't be at all a problem. But just enough on there, a couple, 3-4 layers maybe, up in this area, so that maybe we won't be scratching up and scoring either the flap detent or the flap handle itself. So we're going to give that a try and see how that goes. Like I said, this Plasti Dip stuff is pretty tough and not super spongy or grippy, so I don't think it'll cause drag or, you know, cause it to want to fight me getting the flaps out of a detent. So I'll try it out. Worst case scenario, I can always cut it with the utility knife and strip it off of there if it is binding at all. Obviously I'll test it a bunch on the ground and see how it goes. But that'll have to be kind of part 2, because of course my bandsaw is at the hangar and I'm at home. I'm not going to the hangar today. Also, I'm going to need the bottle jack press that we have at work. So I'll use a V-block and probably you know, a ratchet socket in a V-block to make these bends. And that'll be very simple to do that and get this cut out and cut out the finger holes, and then we'll start plastic dipping. So that'll be part 2. So for now, we showed you cleaning up this flap detent, this new one from the factory, and contouring it out a little bit more and eliminating stress risers. You can see huge improvement versus the one that was in the airplane. And just to show you here the difference in the material thicknesses, there's the old one on the bottom and the new one on the top. And I don't know what I haven't mic'd it, I don't know what the actual material thickness difference is, but that'll help it stay a little more durable as well. Of course, anytime you do that, you're adding weight, but we're talking, you know, grams here, so not a big impact. Definitely well worth it to have the thicker gauge there. Till next time.